All right, so these are the book problems. This is part 3. Um, you need a book, or you at least need to follow along with what I've done. So the first one says to go page 681. So you go to 681, number 15, and it says, Lana has a garden in the shape of a triangle as pictured below. She wants to fill the garden with topsoil. What is the area of the triangle? So you're asked to figure out the area of this triangle. So I gave you the area of a triangle that's not a right triangle is area equals 1/2 A times B times the sine of C. So if I call this A and this B and this C, this would be angle C. Right now I don't know angle C, but I do know a triangle has 180 degrees, and if I add those two angles together, 60 plus 40 is 104. So plus the 4 right there. So that's 104. A triangle has 180, so if I go 180 minus 104, so 180 minus 104 is 76. We get what our angle is. So angle C equals 76 degrees. So I now have the information I need to find the area. So I go 1/2 of 8 times 10 times the sine of 76. So I go back to my calculator, and I go 1/2 times 8 times 10 times the sine of 76. And I hit enter. It tells me the area is 38.8. On that, it has these as being meters. So the area is 38.8 meters squared. All right, on the same page, number 21 says Eric and Zach are camping. Eric leaves Zach at the campsite and walks 4.5 miles. He then turns at a 120-degree angle and walks another 2.5 miles. If Eric were to walk directly back to Zach, how far would he walk? So, some kind of a triangle like that, we want to know the length that he would walk, so this length right here. On this, I know a side followed by an angle followed by a side. If I called this side A, this would be angle A over here. If I call this B, this would be angle B. And this is angle C, and my missing side C. So since I have no pairs of information, I cannot use the law of sines. Like I don't know little a and big A, little b, little c, big C. I don't have any pair of information. But I do have the information, two sides, and an angle, so I can use the law of cosines. The law of cosines says that c squared equals a squared plus b squared minus 2ab cosine of c. So c squared equals a squared, which is 2.5 squared, plus b squared, which is 4.5 squared, minus 2a, so 2.5, times 4.5, because that's the b, times the cosine of 120 degrees. So now I just type that in my calculator, and that'll give me what c squared is. So I go 2.5 squared plus 4.5 squared minus 2 times 2.5 times 4.5 cosine of 120. And I hit enter. And that gives me what c squared is. So now if I just want to know what c is, I go second square root, and I need to square root that answer. So I go second answer. That's a little trick to help you. You just hit that second negative sign. It puts the answer nice and pretty for you in there, and you can hit enter, and it tells you what it is. So the square root of 37.75 is 6.1. In other words, the length that you would have to walk is 6.1 miles, a little more because it's 6.14. That's roughly the length that he'll have to walk to get for Eric to meet back with Zach. So Anyways, that's number 21. Again, you had to use the law of cosines on that. Page 713, number 29. So you go to page 713, and number 29 says a ball is thrown off the edge of the building at an angle of 70 degrees with an initial velocity of 5 meters per second. So here's my initial velocity of 5 meters per second. The equation that represents the horizontal distance of the ball, x, is x equals v naught cosine theta times t. So here's my equation they give me, where v naught, that little zero at the bottom of v means v naught, is the initial velocity, theta is the angle at which it is thrown, and t is the time in seconds. About how far will the ball travel in 10 seconds? So we know the angle is 70 degrees and the time is 10. So all we have to do is plug stuff into that formula which was given. So V naught is 5, so I put 5 here. Cosine of 70 degrees times time. And I just type that in the calculator, and that'll tell me how far that ball was thrown. So 5 times the cosine of 70 times 10. Enter. 17.1 meters. Since this is meters per second, my answer will come out in meters. So that ball was thrown 17.1 meters. And that's all you had to do on that problem. Page 713, number 33. It's a great ship on my triangle, huh? Little boat with a mast and a sail. Kira and Mallory are standing on opposite sides of a river. How far is Kira from the boat? Round to the nearest tent if necessary. And it has the picture drawn. Better than my picture, but it works. So notice, I have an angle and an opposite side that we want to find. I have this piece of information that they're giving me, but I don't have an angle here. So that's what I need, as I cannot have two unknowns. I need a pair of information. But since they gave me 85 and 30, in essence, they gave me this other angle because you know a triangle has 180 degrees. We've used 85 and 30. So I can just go to my calculator and go 180 minus 85 minus 30. Since those are the two sides that we have been, or the two angles that we have been given were 85 and 30. So I just subtract those off. And I hit enter. And it gives me 65 degrees. So this angle is 65 degrees. Now I have a pair of information, and I can use the law of sines. So A over sine A equals B over sine B, which equals C over sine C. All you need is two of them, so I have two pairs of information that I'm looking at. So little a we're going to call 90. Little b we're going to call 6, or little a is capital A, the angle A, there's what I'm trying to say. Capital A, the angle, is 65 degrees. That is the angle opposite of the 90 feet. So I have sine of 65 equals little b. That's the part I don't know. I don't know little b, the side b. So I put little b over the sine of its opposite angle. So sine of 85. So opposite of angle b is the 85 degrees. So I set it up. So now to get rid of divide, I'd multiply the sine of 85. So I'm going to go 90 times the sine of 85 divided by the sine of 65. So I go 90 times the sine of 85. And I'm going to double check, make sure I got that right. 85 divided by the sine of 65. And I hit enter, and it is 98.9. So this side is 98.9 feet away. And that should be bigger than the 90 because 85 degrees is bigger than 65 degrees. So the opposite side should be bigger of the 85 degrees. That's my biggest angle. That should be my biggest side. So the distance from from Kira to the boat is 98.9 degrees, or 98.9 feet. Excuse me. All right, page 714, number 39. It says, a farmer wants to fence a piece of his land. Two sides of the triangle field have lengths of 120 and 325 feet. The measure of the angle between those sides is 70 degrees. How much fencing will the farmer need? So we need to find the missing side before we can add up all of the fencing. So this looks like that law of cosine problem again, where we have an angle, the two adjoining sides, but not the opposite sides. So again, we will use c squared equals a squared plus b squared minus 2ab cosine of c. So c squared we don't know. A squared we'll call 120. B squared we will call 325 minus 2 times 120, 325 cosine of 70. So now I just type that into the calculator. So 120 squared plus 325 squared minus 2 times those two numbers, 120 times 325 cosine of the angle between them, which was this angle right here. So between those two sides that I know, so cosine of 70. This is going to be a big number. So that's what c squared is. So now I want to take the square root of that. So I hit second square root. Not graph. I hit the wrong button on here. Second. So I go second square root of the answer. And I hit enter. It's 305.5 feet. So now you're just going to add those together. 120 plus 325 plus 305.5. So 750.5 feet. So that is the amount of fencing needed to enclose that triangle. All right, page 714, number 45. It says a wheel with a diameter of 18 inches completes 4 revolutions in 1 minute. What is the period of the function that describes the height of one spot on the outside edge of the wheel as a function of time? So it completes 4 revolutions per minute. So the period is how many revolutions, how much time per 1 revolution. So period is time for 1 revolution. So since I make 4 revolutions in 1 minute, the time for 1 revolution is going to be 60 seconds divided by 4. So it takes 15 seconds to complete 1 revolution. So 15 seconds for 1 revolution. So that is the period, is 15 seconds. That whole point, this black point, would go all the way around the wheel in 15 seconds. So I could calculate its time or its placement anywhere on that wheel by knowing the period's 15 seconds and plugging that into the rest of the formula for the sine or cosine. All right. This is page 715. Number 58. So it says the graph below approximates the height y of a rope that 2 people are toiling as a function of time in t seconds. Write an equation for the function. So looking at this picture, first thing I notice is this. So it has a midline at 4. So it has a midline of 4. Okay. the highest point that it goes from the midline is up 4. The lowest point it goes from the midline is down 4. So that means the amplitude is also 4. Now, because at 0, my graph, the midline is on 0. So my graph is on the midline at time 0. That is a sine wave. So whenever the graph, when we're at 0, the graph is on the midline, then we know that it's a sine wave. So I'm going to have f of t, this is time down here. I should have labeled that. So f of t, and these are going by 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, equals the amplitude, which is 4, sine, I'm leaving a space in front of t, plus 4. Okay, now it comes for the tricky part to find the period. If I look at this, I go down, up, and down in 1 second, or in 1 second. I go down, up, and down in 2 seconds. I go down, up, and down in 3 seconds. Down, up, and down in 4 seconds. So I complete 1 revolution in 1 second of time. So each of these is 1 revolution in 1 second of time. So remember, the period is the time for 1 revolution. So if we go to our formula, we also know that the period is always equal to 2 pi over b. And b is what we're after. B is the number that goes right here in front of our angle, in front of our time, or our variable. So I know the period is 1 revolution. So 1 revolution, it takes 1 second for time, whatever this is, second, minutes, whatever, 1 amount of time to go 1 revolution. So that's the period. Equals 2 pi. If you don't want to use 2 pi, that's the same as 360 degrees over b. So to find b, I swap those two, and I get b equals 360 over 1. So I could put 360 degrees, or 360, not degrees, but number 360 in front of that, or 2 pi. And that would be my formula, 4 sine 360t plus 4. So remember, to find the b, you have to say, okay, what's the period? And then you have to remember this formula, period equals 2 pi over b. So the period was 1 second for 1 revolution, so I replaced the period with 1. Then we can go swap those two places, and we get that b equals 2 pi, or 360 degrees. And then you can put b in front of the variable. So that is the equation to model this graph. All right, page 717. Number 25, it says a water wheel has a diameter of 20 feet. It makes 1 complete revolution in 45 seconds. So 1 revolution in 45 seconds. That is the period. Ta-dum. That's the period, okay? 1 revolution in 45 seconds. So 45 seconds, that's the amount of time it takes to make 1 revolution. So that's the period. Let the height of the top of the wheel represent the height at time 0. So the height is at the top of the wheel at 0. So at time equals 0, if I were looking at a graph, the top of the wheel is at time 0. Write an equation for the height of point H in the diagram below as a function of time t. So we have the height is at the top, has a diameter of 20 feet. So that means from here to here is 10, and from here to here is 10. So it looks something kind of like that. So I put here, let's see. So we know the A so we have, that's y equals, well, not, let's not use y, let's use f of t. So the maximum that goes up from the midline is 10, the maximum that goes down is 10, so that's where we start right here is 10. Because it started at the top, so it didn't start at time 0, it didn't start on our midline, so therefore we know it's a cosine wave because it didn't start on our midline. If it starts on our midline, we know it is a sine wave. If it doesn't start on our midline, it's going to be a cosine wave, especially if it's at the top. So 10 cosine. So period is 45 seconds. So remember, t equals 2 pi divided by b. We need to figure out what b is to go right here. So this is b. It goes right here. So we need to figure that out. And I'm going to use 360 degrees instead of 2 pi. We'll use degrees instead of radians on this. So the period is 45, so I have 45 equals that. So I can replace those two. So b equals 360 divided by 45. So if I go to my calculator, 360 divided by 45 is 8. So my b equals 8. So that goes here. We're going in regard to time, so this is going to be a t. And then our midline is at 10. So that would be the equation that would model the height of our paddle wheel at any time. All right, last problem on your pretest. It says Jim walks 50 yards east from his car, then turns north and goes 30 yards. So here's his car, north, east, south, west. So he walks 50 yards east. Then turns north, so he goes north and walks 30 yards. Calculate the angle from the car and the line which runs north. So we're going to calculate that angle. And also, what is the distance? The distance part is easy. We go a squared plus b squared equals c squared. So I can go to my calculator, 30 squared plus 50 squared, and that's what a squared is. So to find out what just a is, I take the square root of 3,400, which is 58.3. So the distance is 58.3. Now to figure out the angle, I'm going to use, this is the opposite side, this is the adjacent side. So I know that's tangent. So tangent of my angle equals 30 over 50. So to figure out what the angle is, that's the inverse tangent. You'll hear it also called arctangent when you're looking for an angle. So tangent, -1, 30 divided by 50. So I go to my calculator, second tangent, 30 divided by 50. And hit enter. So that is 30.96, which is practically 31 degrees. So this angle is 31 degrees. If we wanted to know the other one, we could go 90 minus 31, and that is 59 degrees. So that's all you need to know for that triangle, and that is the end of the pretest.